We will continue with chapter 3, section 2, with finding the trig ratios for angles in standard position at the given point. So in this situation here, what we will do is we'll just plot the point. So negative 2 root 3 and 2, the x is negative, the y is positive, so it's in this quadrant. This is the point P, and it's at negative 2 root 3 and 2. So all we need to do, as this is the x-axis, this is the y-axis, we drop a vertical to the x-axis, always not with the y-axis. At 90 degrees, this will be negative 2 root 3, and the y will be 2. Now we could use Pythagoras to find out what the hypotenuse is, and the hypotenuse here will be negative 2 root 3 squared plus 2 squared will equal c squared. That's 4 times 3, 12, plus 4 c squared. So 12 plus 4 is 16. Square root of 16 is 4, so c equals 4. So therefore, we just found out that this is 4. Now I could find out what my sine x is, sorry, sine theta. And always that's where we put theta between the terminal arm. We call this the terminal arm and the x-axis. So it will be 2. So the sine will be opposite over hypotenuse, so 2 over 4, which reduces to 1/2. The cos theta would be adjacent, which is negative 2 root 3 over the hypotenuse, which is 4, and that will give me negative root 3 over 2 when you reduce. And then we'll do tan theta. And tan theta is opposite over adjacent, so 2 over negative 2 root 3, which gives me negative 1 over root 3 if you wish. And you could rationalize the denominator by multiplying top and bottom by root 3, and that will end up giving you negative root 3 over 3. And that's your final answer for this one. Also, with the unit circle, we could also use something called the sine equals y over the radius. Cosine is adjacent. Oh, sorry, cosine is x over the radius. So that's x right there. And the tangent is y over x. That's another way of doing it, because when you're dealing with angles in standard position, you could do that as well. So sine would be y, the y value over the radius. Cosine would be the x value over the radius, and the tan will be the y over the x. So either way, that's fine. I usually use this. The next thing I'm going to do is the second question. And the second question, if I graph it, negative 3, the x is negative and the y is negative, so my terminal arm should be right here. Make right angle there, so the x, so this is the point, which is negative 3 and negative 3. So the x value is negative 3, the y value is negative 3. Find the, if we want to find the hypotenuse, then we just use Pythagoras. So that's negative 3 squared is 9. and that's 9. 9 plus 9 is 18. So c squared equals 18. I'm gonna square root both sides, so c would equal square root of 18, which is 18 is the same as 9 times 2, which change it to mixed radical and will be 3 root 2. So that's what the hypotenuse is, 3 root 2. And therefore, if I want to find sine theta, and also theta is always between the terminal arm and the x-axis, sine theta would be opposite over hypotenuse, so negative 3 over 3 root 2, which gives me negative 1 over root 2. And if you want to rationalize the denominator, you multiply top and bottom by root 2, and you get negative root 2 over 2. Cosine is going to be the same thing, negative root 2 over 2. And the reason is the sine and the cos, they equal the same thing since the adjacent and the opposite are the same. And the tangent would be, tan theta would be opposite, which is negative 3 over adjacent, which is negative 3, which gives me 1. So this is it for this. We'll explore some more questions next time. I'll see you later.